We're going to be talking about correlation. Correlation is letting you know if you were to put a line on a scatter plot, how that would affect, how closely that line would be to the rest of your data. So we're actually going to be looking at linear data, and linear means that we're looking for a line in the form, sorry, got some issues here. Sorry about that, just recalibrated there. But so linear is in the form of y equals mx plus b. And we've talked about y equals mx plus b. It's your most basic form of a line. With that though, so we've got a scatter plot. And we just got done talking about what a scatter plot is. So we've got all this data. And what you're trying to do is you are trying to find a line that can go through your data and most likely hit most of your data points. We'll talk about how to find that line based on the next video, but I want to talk specifically about correlation first. So with correlation, we have a difference of negative versus positive. So negative is going to be going, most of your data is going in the negative direction. Okay. Positive, as you can guess, is going to be going in the positive direction. Then we also have strong versus weak. A strong correlation is going to be that the data is very tight and it's going to be very easy to get a line, or the line of best fit is going to be very close to hitting all of those points. A weak correlation is going to be kind of spread out a little bit, but you can still kind of see where we're going. And then there is also the potential to have none. And it just looks like a bunch of polka dots. So there, we aren't going to say it's necessarily positive or negative, and we can't say it's strong or weak. It's absolutely none. So with that, we also have what we call a correlation coefficient. And this is what I'm going to show you how to find on your calculator. With this, the correlation coefficient, you have a range. You go from -1 to 1. -1 means you're going to have a strong negative. 0 gives you weak. 1 gives you strong positive. So you might have like a 0.8. A 0.8 we would say is pretty close to strong positive. So this just kind of gives you a range. On our calculators, it's going to be an R equals some number. If it's -0.67, okay, that's what we got. So looking at this, we're going to have some data here. So from our calculators, and you guys will get calculator notes for this, we're going to go add list and spreadsheets. I'm going to say that this is X. We're just going real basic here. Let's say that we're looking at the amount of time you study and your test score. Is there an actual correlation? So I'm just going to throw in 5 data points. That way you guys don't have to scroll down. So let's say we go 26. Won't actually type for me. silly. So I've got 26 in this spot. Let's go with another 30. Let's say 40, 45, and let's go 60. Okay, so then over here we got our Y. Our 1, let's go with, let's say they got a score of 70. For 30 minutes, they got a score of 80. 40 minutes, they got a score of 75. 45 minutes, 85. 60 minutes, 88. Okay, so now I've got my time, and then I've got my test score. Okay, so I want to find the correlation coefficient from here. So I'm going to go to Menu. I'm going to go to Statistics, Stat Calculations. Again, we're looking for a linear correlation, so we're going to go Linear Regression. We're going to choose our X as our X and our Y as our Y. Nothing else should change, and we'll hit OK, and we got our information. Now, if you look here, that R value is 0.83. So I found my R value, so it's a 0.83, and we're going to say that this is a strong positive correlation. So with that, we can say that there is a likely chance that the more time you put into studying, the better you will do on your test score. Now, it all depends on the data. Sometimes your data may be really spread out, and you will see that with that correlation that it's closer to 0 and that there's no correlation. Or it's really strong and you can see that. The other thing that we need to talk about is causation versus correlation. So a causation means that you are going to have a cause and an effect. This means that you are going to have a very, very strong likelihood that if this happens, if this is the cause, then this will happen. So, for instance, something that we always talk about when you're looking at collecting data and stuff, and you're looking at causation versus correlation. A correlation is a likelihood. So a causation, a great example is if I eat over 2,000 calories, I am going to gain weight. Okay, a correlation, a good example, and correlation kind of is, you know, we just looked at, does it necessarily mean that if you study more, your quiz grade or test grade will go up? No, that is not a guarantee. Or causation, you can think of it as it will happen, guaranteed, no questions asked. So that's something to note. We'll talk about more of this in class, and I'll give you different scenarios, and you guys will be saying whether it is a causation or a correlation. Other than that, we're just looking at the graphs. We'll talk about the line of best fit for your scatter plot in the next video.